I'm going to do about processor and its language, which we call the low-level language. Okay, so let's see. Since the processor is responsible for executing, that is, processor is the one who is going to do the instructions and handle the data provided to it. So it has to understand a language. Otherwise, these instructions are given to the processor, so it understands that particular language in which these instructions are given. So because it can understand only, it's able to do that, right? So it understands, and this language that the processor understands is called the machine language, and it is in binary, that is zeros and ones. This language is embedded into the processor at the manufacturing time by the manufacturer. So how does the processor understand the instruction? With electronics, they have made this processor such that these are embedded into the processor itself, and at the time it's being made. So once it is made, it's permanently fixed in there, and that's the instruction it will understand. So once the processor is manufactured, the processor will only understand those embedded languages instruction set, okay, because it's already done. So just imagine it's something like a ROM in a way. It won't get erased or anything like that. The processor is wired in such a way, when that instruction is given, it understands that, and whatever that instruction is supposed to do, the processor will do. For example, if the processor is made with 100 instructions embedded, so suppose say a manufacturer designs a processor and puts 100 instructions into it by way of electronics or circuits or whatever, and embed it and fix it to the processor, those are the 100 instructions that particular processor will understand. Okay, so this is being fed in by the manufacturer, and it's done at that point in time. And other than these 100 instructions, if you try to give any other instruction for this particular processor, it will not work. It won't be able to do, because it only understands these 100 instructions. So since we are talking about computers as digital computers, it always works with zeros and ones. Okay, that is 1.8 volts and 5 volts, as we have seen in our previous videos. Its language is so because of that, everything is zeros and ones. The language also is in zeros and ones. It's in binary. Okay. There are many manufacturers' processors available in the market. So different manufacturers have made processors available with that particular processor's instruction set already embedded into it. So one manufacturer's processor and another manufacturer's processor need not be the same, because it's being manufactured by two different people. They decide what to put into that, and that's what that particular processor will do. Okay, so if the two processors are identical, what's the point? So each one will do their own thing, and even instruction set can differ. Okay, so into that, so, you must have heard of already Intel processors, AMD, and there were things like 6502 earlier, Z80. So these are different processors manufactured by different manufacturers. Now, so these manufacturers manufactured processors are taken by whoever is making computers, and they put it into the computer. So that computer has that particular processor. Okay. So like this, each of these processors are utilized by different companies to make computers, and they feed into that. So all the computers do not use the same processor. Okay. One computer might use Intel, somebody else might use AMD, somebody else might use 6502, somebody else might use Z80. So like that, each computer can have different processors. Since these instruction sets are embedded by the manufacturer into the processor, the computer having processor manufactured by one manufacturer generally will not understand the instruction set in a processor that is manufactured by another manufacturer. Like I told you earlier, one manufacturer is making his own processor with his own set of instructions. Another manufacturer is making his processor with his own instruction set. So if you try to take A, say let's say processor A and B, if you try to take the instruction set for A and try to apply it on B, B might not work, because B might not understand those instructions. Maybe the person who manufactured the B didn't put those instructions into the processor. So that's the reason why they may not work. Okay. Remember, instructions will be in zeros and ones, like I told you earlier, because it's in binary. Okay, the computers work in binary. Its instructions are also in binary. So let's see an example. Let's take two processors. Okay, well, let's first look at processor A, and for simplicity's sake, we will assume the processor has only two instructions. Okay, for explanation purpose, I am just reducing it to two instructions only. Okay, but generally a processor will have a lot of instructions that embedded into that. So we'll say the processor A manufacturer has put a instruction called 000110, that is this particular one, and let's say he makes the circuit in such a way that if this instruction comes, it means add to the processor. Okay, so that's the hardware part. We don't have to really understand that. That's how the processor is made. And let's assume 10001100 is subtract. That means when processor A gets this instruction, that is 10001100, the processor A understands it's a subtraction operation that it has to do. If this comes in, then the processor A will decide, okay, it's an add operation that it has to do. Similarly, let's take processor B, another processor manufactured by somebody else, that also will assume has two instructions. Let's say he is also planning to put a add and subtract. So he puts add, and his add may be totally different to the add here. So in this processor, if you want to add, you have to give 11110011, whereas in this processor you have to give 00001100 for add. And just to confuse you all, I decided to put another one similar to this one. In this processor, 00001100 is subtract. The manufacturer has made it like that. But in this processor A, that same code 00001100 is add. So what is add in this processor is subtract in this processor. It can be. I'm just taking this as an example. It's not always the case, but just to show you how different the two processors can be. This is manufactured by one person, one manufacturer. This is manufactured by another one. So he has put these two instructions as add and subtract. He has put these two instructions as add and subtract. So hence, instructions written for processor A will not work for processor B and vice versa. For example, if I want to add, I have to give in processor A, I have to give this instruction. If I want to add in processor B, I have to give in this instruction. If I take this instruction and give it to A, it may not understand. Or worst case, look at this example. If I take this 00001100, which is add, and give to this processor, he will understand it as add. Whereas if I give the same thing, which is this, to this processor, it will understand it as subtract. So that's the two processors are different. So if you are writing to one processor, that processor's instruction set only you can use. If you are writing to another processor, you have to use the instruction set provided by that manufacturer. And that is why A will not work on B and B will not work on A. Instructions belonging to B will not work on A. Instructions belonging to A will not work on B. Okay. So machine language therefore is processor dependent. Why? This language can only work in this processor. It can't work in this one. So it is processor dependent. Same way, this language can only work in this processor. It will not work in this processor. Again, machine language is therefore processor dependent. Right? So machine language is 00, this part. Add, subtract. In this processor, add, subtract. This is machine language.